Hello, class. This is Mrs. Bishop, and we will begin our online class for 100 to finish the semester on March 30th, which is tomorrow. Right now, I'm going to kind of go over the concepts we've covered in Unit 2 because you are going to be taking a test on it next week. So grab a pencil and let's get started. First of all, we reviewed fractions and decimals and percents. To change a fraction, such as 4/5, to a decimal, you divide the numerator by the denominator. So 4 divided by 5 is equal to 0.8. To change from the percent from the decimal to a percent, you move the decimal 2 places to the right, and that would be 80%. You need to be proficient at going from fraction to decimal to percent and back again. For instance, if you have 3.2 and you want to change that to a percent, once again you move the decimal 2 places to the right. 1, 2, and fill in with a 0, so it's 320%. Now, if I have the percent 25% and I'm asked to change it to a decimal, I will take off the percent sign and move the decimal 2 places to the left. So that will be 0.25 as a decimal, and you would read that 25 hundredths because it's in the hundredths place. So to make a fraction, you do the 25 hundredths. The number of numbers to the right of the decimal will tell you the number of zeros you're going to have. Simplify that to 1/4. Once again, you need to be taking notes on this. And if you'll give me just a minute, I'll erase this and put some more on there. Okay, then we talked about absolute value. Remember that the absolute value is never negative because it represents distance. It represents the distance from 0. So on a graph, if I'm going to graph the absolute value of 3, I will make my line graph, put 0 on there, 1, 2, 3. 1, 2, 3 has a distance of 3. And going the other direction, 1, 2, 3 has a distance of 3. So the absolute value of 3 can be either a -3 or a +3. Then we talked about solving equations. If I have the absolute value of x is equal to 5, then x can be a +5 or a -5, just as in our example with 3. And now I'm going to solve some equations with the absolute value. Again, this should just be a review for you because most of you have already handed this in. And remember, it can never be negative because distance cannot be negative. Okay, so if I have the absolute value of 2x plus 3 is equal to 9, you must set up two cases, one for the positive and one for the negative. Take off the absolute value signs and just take your 2x plus 3, set it up equal to 9. That will be case 1. And then case 2, you set it up equal to a negative 9. 2x plus 3 is equal to negative 9. So yes, you're going to have two answers. We will isolate the 2x by subtracting the 3 from both sides. 2x then is equal to 6. This has been multiplied, so I'm going to divide by 2. So x is equal to 3. Then I come over here and solve the case 2. Again, I'm going to isolate the 2x, so I'll subtract 3 from both sides. So 2x is equal to negative 12. Divide by 2, divide by 2. So x, my friend, is equal to negative 6. So you have two answers. X can be 3 or x can be negative 6. Now, if I had another problem over here where x, absolute value of x plus 5 is equal to 0. I'm sorry, I meant to say equal to negative 3. It's a no solution because absolute value can never be equal to a negative number. Now, if I had x subtract 3, absolute value, is equal to 0, then I would again take x minus 3 out of the absolute value sign and set it up equal to 0. Since it's 0, it won't be positive or negative, so you're just going to have to solve one equation by adding 3 to both sides. That's supposed to be an add sign. So x is equal to 0 plus 3 is 3. So on this one, if it's equal to 0, it'll just have one answer. If it's equal to a negative 3, it's no solution. And if it has two cases, you'll have two answers, like on this one was 3 and negative 6. Okay, let's move on now. I hope you all are staying safe and staying well. To get your homework to me, it'd be great if you could scan it and email it to me, but if you can't do that, we'll do it by text, or you can snail mail it to me if you want to do that. Okay, moving on now. I want to do just a couple more examples with the absolute value. If you have the absolute value of x plus 5 is equal to 13, this 5 is not inside the absolute value sign, so we must move it first. So I'm going to subtract 5 from both sides. So then I'm going to have the absolute value of x is equal to 8. So x can be a positive 8 or a negative 8. Two answers. Always isolate what's inside the absolute value sign. Another example of that would be on this one. M plus 2 plus 5 is equal to 30. Once again, this 5 must be moved by subtracting it. Before we do anything with the absolute value, you've got to have only the absolute value on the left side. So When I subtract 5, I'm going to have 25. So case 1 would be m plus 2 is equal to 25. Case 2 would be m plus 2 is equal to negative 25. Solving, I will subtract 2 from both sides, and m is equal to 23, or over here when I subtract 2 from both sides, m will equal negative 27. So that's your two answers for that. One more example, then we're going to move on to radicals. Or I think we'll do rationals first. If I have the absolute value of 5x plus 10 is equal to negative 11. No solution because absolute value represents distance and distance cannot be negative. Okay, if you're not keeping up, you can go back and watch this again and again. This is the stuff you're going to have to know for your test. Okay, moving right along, then we covered rational equations. Rational means fractions. And a rational equation is one that has a variable in the denominator. Such as, say, 2 over x. It's a fraction, it has a variable in the denominator. Again, we're going to use inverse operations to isolate the variable, or we can use proportions, where you cross multiply and the cross products are equal. Or we can multiply the equation by a common denominator and then solve the resulting equation. And don't forget, the denominator of a fraction cannot equal 0. The values that make the denominator of 0 are called restrictions. So in this case, x cannot be 0. That's a restriction. If I have 2 over x plus 3, then x plus 3 cannot equal 0, so I need to solve that and subtract 3 from both sides. So my restriction is x cannot equal negative 3. So keep that in mind. When you're working these, you may have to show me what the restrictions are. It just means that it cannot equal 0. Okay, moving on to some examples. You really should probably already have these in your notes, but I'm just going over them just in case you need a little help. When I have 3 over x plus 2 is equal to 2 over x, this is a proportion. Proportions are kind of neat if you can set a problem up to work it as a proportion. You cross multiply. 3 times x is 3x. Cross multiply here equals 2 times x plus 2. First thing we need to do, is to distribute. So I'm going to have 3x on this side is equal to 2x plus 4. Then I need to move this guy to join his friend over on this side, which means I need to subtract him off here and subtract him off here. I'm left with 1x over here and a 4 over here, so you're finished. X is equal to 4. Now that wasn't so bad, was it? Now, if I wanted to get my restrictions for this problem, what can x not be? Well, first of all, it cannot be 0. X cannot be 0 because there was an x right there in the denominator. And then x plus 2 cannot equal 0. So if I subtract 2 from both sides, x cannot equal negative 2. Okay, moving on to the next one. Again, this should just be review. I just was afraid you might have forgotten some since you've been off so long for spring break and extended spring break and on and on and on. So the next one, x plus 5 over x minus 2 is equal to 0. Remember, you can always make a 0 into a fraction or any whole number into a fraction by putting a 1 on the bottom. Again, I'm going to cross multiply. X plus 5 is equal to 0 times anything is 0, so there I have it. So I'm going to subtract 5 off both sides, and we're left with x is equal to negative 5. Now, does that have any restrictions? Yes, it does. Right here, x subtract 2 cannot equal 0. So when I add 2 to both sides, I end up with my restriction being x cannot equal 2. So your answer is negative 5. Your restriction is cannot be equal to negative 2. The next example is going to be 1 over x plus 2 over x equals 6. Now notice the denominators are the same here, so I can just add my numerators and get 3 over x is equal to 6. And remember, I can put that a 1 under there to make it into a fraction. So cross multiply, so I have 6x is equal to 3, divide by 6, divide by 6, and x is equal to 3 over 6, which you simplify to 1 over 2. On this one, the only thing x cannot equal is 0 because that's what's on the bottom. So x cannot equal 0. X does equal 1/2. The next example, 1 over x plus 1 over 3 equals 1/5. Notice this number and this number are fractions, and so what I'm going to do is move the 1/3 over here by subtracting it. So now I subtracted from both sides, so I have 1 over x is equal to 1/5 minus 1/3. And you can use your calculator to do that. You end up with negative 2 over 15. And then again, you can cross multiply and you'll have negative 2x is equal to 15. X is equal to 15 over negative 2. If you want to change that to negative 7.5, feel free. Okay, then you had your assignment, and nobody has handed that in yet, so be sure and get that to me as soon as possible. It looks like this. Well, that has the answers on it, so I won't hold it up there very long. I don't know if you can even see that or not. Okay, now we're going to look at radicals. Radicals. A radical sign looks like that. If there's not an index number in here, it's automatically 2. So if I want it to be 3, I'm going to have to write it in there. If I want it to be anything except 2, I have to write it in there. So if you see it and it's just this and you have a 5 in there, that means square root of 5. If I have 3 on the outside and a y on the inside, that's 3 times the square root of y. This would be the 6th root of 15. This would be 5 plus the square root of 9. Whoops, put the 9 in the wrong place. 9. That's a 2 there if there's nothing given. So this is called the radicand. This is called the index or the root. Again, you should have all these notes. I'm just reviewing them with you. So if you remember, the opposite of addition is what? Yep, you're right, it's subtraction. The opposite of multiplication is? Yep, you're right, it's division. So the opposite of squaring a number is like if I have x squared, the opposite would be to take the square root of x squared, which would be x. So radicals are the opposite operation of applying exponents. So we can undo the power with a radical. And we can undo a radical with a power. So 2 squared is equal to 4. So the square root of 4 is equal to 2, which is the base over here. And then we did these together in class. If you remember, you should have it on there. The square root of 49 is 7. You write a few of these down there. I'm sure you have them there in front of you. So if I have the square root of 49, it's actually plus or minus 7. But if it doesn't ask you for both of them, then you'll just use the positive one. If I have a negative on the outside, like the square negative, the square root of 289, see if you can put that in your calculator and work it out. Okay, when you work it out, you get 17, so you bring the negative over like that. You can't have a negative on the inside for the square root. So if I have the cubed root, say, of 1, remember you can, that's on your calculator, and you can put the 3 in for the x and the absolute value. If the cubed root of 1 is equal to 1, you might want to get out your paper I gave you. They gave you perfect cubes and perfect squares. Okay, and another thing, if you have the square root of 9 over 16, you can separate those out. It's going to be the square root of 9 over the square root of 16, which is going to be 3 over 4. Okay, let you think about that for just a minute. And then we did some problems with the radical signs. And then we talked about the Pythagorean theorem, which was a right triangle. And it was a squared plus b squared is equal to c squared, where we have to use our radical. So if we have this right triangle, and this leg was 6 inches, A, and this leg, B, was 12 inches, and we had to find C, or sometimes you can call it X, then we would put that up here in this equation, and we'd say 6 squared plus 12 squared equals C squared. Well, 6 squared is 36, 12 squared is 144. So when I add those together, I'm going to get 180. So C squared, or X squared, whichever you want to call it, is equal to 180. I must take the square root of C squared to get C and the square root of 180 to get the answer. So the square root of 180 is equal to 13.41, blah, 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 rounded off to the nearest tenth, which would be 13.4. Okay, now, the other thing that you're going to have to know, and we talked about this some the last night of class, was ratios. Ratios is simply comparing two numbers in fractions. Like if there is 5 girls and 4 boys in a class, the total would be 9. If I want the ratio of boys to girls, then it's going to be 4/5, or you can write it 4/5, or you can write it 4.5. Usually you'll just use that one. Okay, so what would be the ratio of the girls to the total? Well, there's 5 girls, total of 9, so it would be 5:9. I want to remind you that the word of means to multiply. So if I have 1/5 of 100, you would in your calculator put 1/5 times 100 and you would get 20. So just remember that of means to multiply. And if you have like 80 is means equal. 25% of what number? Then you would say 80 equals 0.25 of means times x, which would be our unknown. Then you would divide both sides by 0.25, which would be 80 divided by 0.25, which is equal to 320. So x would be 320. And one more thing I want to remind you of is that natural numbers, if I ask you to count, I believe Aaron, I asked you to count when we were talking about this, you said 1, 2, 3, and so forth, and that was perfect. Then we did the whole numbers, which includes 0, 1, 2, 3, and so forth. Then we had the integers, integers, which was -3, -2, -1, 0, and 1, 2, 3. It just added the negative numbers to that set. Notice we have no fractions there. So then we add fractions, which is the rational numbers. You will have to know these terms for your test. And then we have irrational numbers. Irrational numbers are numbers like the square root of 2. Put that in your calculator. It doesn't have a repeating decimal. Or the square root of 7. The most common one is pi. Alrighty, class, I know that was a lot to cover, but you are going to be having a test over all this next week, and I just want to refresh your memory in case you didn't get your homework done. I need that all that homework I assigned, I need it by Tuesday, March 31st. I hope you all are staying safe and staying well, and I'm sorry that we're having to go through this crisis, but perhaps it will help us to examine our lives and make sure we are doing what's right. Have a good evening.